July 9th, 1962, 11 o'clock at night, Honolulu. The hotels are running rooftop parties. Families are parked on hillsides above Pearl Harbor looking west because the newspapers have promised a show. Tonight, 900 miles away and 250 miles straight up, the United States is going to detonate a hydrogen bomb in space. The sky ignites. Red, then green, then a slow artificial dawn that hangs over the Pacific. And down in the streets of Honolulu, about 300 streetlights go dark. That was the damage. The most famous electromagnetic pulse in history, the event every EMP documentary is built on, tripped a few dozen fuses and darkened around 3% of one island's streetlights. The phones kept working, the radios kept playing, nobody's car stopped, the fuses were reset. The real destruction from that night was invisible, because it happened in orbit, and it took months. The blast pumped a belt of radiation around the Earth, and that belt slowly cooked the electronics of the satellites passing through it. Half a dozen failed or degraded in the months that followed, including Telstar 1, launched the very next day. The only large EMP test ever conducted did its damage not with the pulse itself, but with the environment it left behind. So, the story you've heard, every vehicle dead on the freeway, 90% of Americans gone within a year, where did that come from? Is any of it real? Parts of the nightmare are pure invention, but one part of it is real. It has gotten worse every single year since 1962, and almost nobody is pointing at the right piece. Let's take it apart. Starting with the pulse itself. Here's the first thing almost nobody knows. An EMP is not one pulse, it's three, and they attack completely different things. When a nuclear weapon detonates above the atmosphere, its gamma rays slam into air molecules far below and knock their electrons loose. The Earth's magnetic field grabs those electrons and whips them into a curve, billions of them turning together in sync. That synchronized turn broadcasts a pulse called E1. E1 is fast beyond intuition. It rises in a few billionths of a second, and it can reach 50,000 volts per meter. It is so fast that ordinary surge protectors never see it. By the time they react, measured in millionths of a second, the pulse has already come and gone. E1 couples into short conductors, circuit boards, antenna leads, the wiring inside your walls. Then comes E2, slower, weaker, and boring. E2 behaves almost exactly like lightning, and the world already knows how to handle lightning. It's the one part of the weapon we've accidentally spent a century defending against. And then, over the following seconds, comes E3. E3 is not really a pulse at all. It's the Earth's own magnetic field, distorted by the explosion, slowly heaving back into place. That heave pushes current into the longest conductors on the planet. Transmission lines running for hundreds of miles. E3 barely notices your laptop. E3 is aimed by physics itself at the grid. One flash, three different weapons. The pulse that threatens your phone and the pulse that threatens the country are not the same event. And almost everything the movies get wrong comes from mashing them together. So walk it forward. The flash happens high over the middle of America. What actually dies? Start with the image everyone carries, the freeway, every engine cutting out at once. The government tested this. The Congressional EMP Commission put 37 cars and 18 trucks into a pulse simulator and hit them with fields approaching 50,000 volts per meter. Cars that were switched off showed no effects at all. They started right up. Of the cars running during the pulse, 3 stalled. They coasted to a stop and restarted. Not one car was permanently disabled. Now, the honest caveats. The vehicles were borrowed and had to be returned working, so testers backed off the moment anything glitched. And that test fleet is decades old now. A modern car carries far more electronics than anything they tested. Nobody truly knows how today's fleet would respond, but the defining image of the genre, every car dying at the same instant, was put in a laboratory, and it did not happen. Here's the twist though. Your car surviving doesn't matter. The pumps at every gas station in America run on grid power. After the pulse, your car works exactly as long as the fuel already in its tank. And then it's a 2-ton paperweight. The vehicle was never the weak point, the supply chain behind it was. Hold on to that pattern. The device survives, the system behind it dies. It's the true shape of this entire disaster. Watch it repeat. Because while E1 was flickering across circuit boards, E3 arrived, and it went looking for wires 100 miles long. We've known wires do this since before the light bulb. In September of 1859, the most intense solar storm in recorded history hit a planet whose only long conductors were telegraph lines, and the storm found every one of them. Operators were shocked at their keys, equipment threw sparks, and on some lines the induced current was strong enough that operators disconnected their batteries and kept transmitting, powered by the storm itself. The lesson of 1859 is not that the past got lucky, it's that this vulnerability scales with wire, and no civilization has ever strung more wire than ours. Nature has even run the modern version of the experiment. In March of 1989, a severe solar storm pushed currents into the power grid of Quebec, the same slow heave as E3 delivered by the sun. The entire provincial grid, 6 million people, collapsed in 92 seconds. And here's the half of that story nobody quotes. It was back in about 9 hours. 9 hours, not 9 months. The grid's protective relays saw the fault and tripped the system offline. The grid essentially fainted before it could be cooked. That fast collapse is a defense mechanism. During the same storm at a nuclear plant in New Jersey where the protection didn't act in time, a massive transformer was damaged beyond repair. That's the fork in the road. Trip in time and you get Quebec. A blackout measured in hours. Trip too late and you start destroying transformers. And transformers are where this stops being an electrical story and becomes a freight story. The largest transformers on the grid are custom built, one at a time, mostly overseas. Each one weighs hundreds of tons. Before the pandemic, you could order one and wait about a year. Today, lead times on the biggest units run 3 to 6 years. But the wait isn't even the worst part, because when your transformer finally exists, you have to move a machine the weight of a blue whale across the country. That requires a specialized rail car. It's called a Schnabel car. And in all of North America, there are only about 30 of them. Top speed, loaded, roughly 15 miles an hour. You can have the money, the crews, and the engineering, and lose years to a shortage of rail cars. If a worst-case E3 destroyed transformers across several regions at once, recovery wouldn't be limited by knowledge. It would be limited by the existence of 30 very slow trains. One more thing the movies get exactly backwards. The pulse is not strongest at ground zero. E1's strength depends on the angle between the blast and the Earth's magnetic field lines. For a detonation over the United States, that geometry pushes the strongest fields hundreds of miles south of the burst point and leaves a relative weak spot, almost directly underneath the bomb. The damage map of an EMP isn't a bullseye, it's a lopsided grin drawn by magnetism. Where you live matters more than how close you are. So assume the bad version. The grid is down across a wide region and it is not coming back in 9 hours. What is the actual survival clock? It isn't your phone, it isn't food, it's the water. Every American city moves its water with electric pumps. When the pumps stop, pressure dies. In high-rise buildings, the taps above roughly the 6th floor go dry almost immediately. Treatment plants stop treating. And the sewage system, which also runs on pumps, begins backing up within hours. You can live 3 weeks without food, you get about 3 days without water, and history is brutally clear about what a city without working sanitation produces: cholera, dysentery, typhoid. In a long blackout, the first mass killer isn't starvation and it isn't violence, it's plumbing. If you've seen our video on the water grid failing, you already know this clock. An EMP simply presses that button, along with every other button, at the same time. And quietly, in the background, another countdown is running. Every nuclear plant in the affected zone shut itself down automatically the instant the grid failed. That's by design, but a shutdown reactor still needs cooling, so each plant switched to emergency diesel generators with fuel on site measured in days and batteries behind them measured in hours. The buildings that made the power have just become the buildings most desperate to receive it. Fukushima was the demonstration of what happens when a station stays dark too long. Within hours of the pulse, keeping those generators fed becomes one of the most important logistics problems in the country. Which brings us to the number, the famous one: 9 out of 10 Americans dead within a year. You've heard it in documentaries, in hearings, in novels. It is the single most repeated statistic in this entire subject. Here is what it actually is. The figure traces back to congressional testimony. Officials connected to the EMP Commission told Congress that an indefinite grid collapse could lead to the death of up to 90% of Americans within a year. Testimony. An estimate offered in a hearing room. There is no published model behind it, no methodology anyone can check, no study you can read. Critics have pointed this out for years. The number acquired the authority of science through repetition alone. That does not make the risk fake. The transformer problem is real. The water clock is real. But this channel gives you real numbers, and the real answer is that nobody, not the Commission, not its critics, not this video, has a defensible count of what a continental grid failure would cost. Anyone who hands you a confident percentage is reading fiction aloud. So what actually works? One last correction, because the most repeated piece of EMP advice is wrong too. You'll be told to build a Faraday cage and to ground it. Here's the thing, grounding does nothing. A sealed metal container shields whatever is inside, whether it touches the earth or not. That is simply how shielding works. What defeats a Faraday cage isn't a missing ground wire, it's gaps, seams, and above all, any cable running into the container, which acts as an antenna and delivers the pulse straight inside. A perfectly grounded cage with a charging cable through the wall is not a cage, it's a delivery system. And the microwave oven trick? A microwave is engineered to contain one frequency, the one it cooks with. E1 is broadband, some of it walks straight through. A plain metal trash can with a tight lid does more than the appliance everyone recommends. So, how long could you survive an EMP? The pulse itself? You survive. Everyone does. An EMP has never directly killed a single human being. If your region gets the Quebec version, the grid faints and wakes up, your answer is measured in hours. And your biggest danger was the traffic lights going dark. If your region gets the transformer version, the answer stops being about the weapon at all. The killing window is the first 3 weeks, the water clock, the sanitation clock, the pharmacy clock. And crossing that window comes down to the most boring preparation on earth. Stored water, about 1 gallon per person per day, and a way to make more of it safe. The weapon fires in a billionth of a second. The dying, if it comes, arrives through the plumbing. Weeks later, beat the water clock, and the honest answer is you could survive a very long time in a much darker, much quieter country. In 1962, we set the sky on fire above the Pacific, and about 300 streetlights blinked out. It was gentle for one reason. The world of 1962 ran on vacuum tubes, technology that shrugs off surges no modern microchip can survive. Every year since, our machines have grown faster, smaller, and softer. The weapon hasn't changed in 60 years. We're the ones who changed.